Hello guys and welcome back to Easy Stats with Danny, and today we're doing study unit 1 part 2, which is multiple regression. It's chapter 12 in the uh, new textbook, uh, and it's chapter 14 in the old one. So today we're going to be doing multiple regression, and these are our study outcomes. So we're just going to be going continue from what we did in the last video. So basically, we learned that multiple regression is about the relationship between the independent and the dependent variable, which is the x and the y variable, respectively. So now today we're going to be sorry for this. Today we'll be focusing on multiple regression. So basically, multiple regression is more than one independent variable. We're focusing on more than one independent variable. If you can remember, we were dealing with y is equals to a plus bx, a plus bx. So it was just only one independent variable x. So now we'll be dealing with more than one independent variable. Like for example, in the video that we just we did, we saw that we were determining the number of sneakers sold based on an Instagram post. So that could be one of the variables leading to a number of sneakers being sold, but there could be other variables, like for example, the price. Let's say in week one the sneakers were 1,000 rands, and then in week two the sneakers are now uh, 700 rands, so that is 300 rand discount. So that can actually determine the number of it can actually influence, not determine, influence the number of sneakers being sold. Now that the price is low, there can be more sneakers being sold. You understand? And then on top of that, the next week, maybe let's say there's another a post, but now it's not on Instagram because not everyone is on Instagram. Now let's say maybe it's other social media platforms like TikTok and Facebook for those who doesn't have who don't have Instagram. So all those things are the variables that can influence the outcome of the dependent variable, being the y variable. So now today we'll be dealing with all of those, and that is just the introduction about multiple regression. All right. So now you'll be given what we call a stat 1.2 output. So I'm going to show you guys now what a stat 1.2 output looks like. They won't ask you to do or perform the output. They will give you the output, and then they'll ask you questions based on that output. Right? Okay. So these are all that you need to know based on the multiple regression. So we're going to have a question from one of the previous question papers, which includes all of them, and then we're going to use those questions to tackle all these study outcomes. Right. So I'm just going to scroll down and show you what a stat 1.2 output looks like. All right. So this is what a stat 1.2 output looks like. So now they'll give you a scenario, and then they'll give you a stat 1.2 output, and then they'll ask you questions. So this is a typical type of a question. This is one of the previous exam papers basically. So I just cropped out study unit 1, uh, specifically multiple regression for this video especially, right? So without further ado, let's dive into this question and tackle all those questions over there. So let me just do this and see. The first one says write down the least squares regression equation. As you guys can see, that is one of the output study outcomes. It says write down the least squares regression equation. But before we do that, we have to read our scenario and analyze the stat 1.2 output, and then we'll answer that question. The question says you are a public health researcher interested in social factors that influence heart diseases. You surveyed 30 towns and gathered data on the percentage of people who smoke, which is X1. That is one of the independent variables. So the people who smoke, the percentage of people who smoke, and then the percentage of people who ride a bike to work. So basically, people who exercise, and then the percentage of people who have extremely stressful jobs. So and the percentage of people in each town who have heart diseases. So heart disease in this case is our y variable, and our y variable is our is our dependent variable. And then we have x1, x2, and x3, which are our independent variables. So we use those to determine the uh, percentage of people with heart diseases. To use multiple linear regression to analyze the relationship between these variables and obtain the following uh, STTN122 output. Use this information to answer the following questions. So these are the questions. So now the first thing that I want us to do is uh, to write down the equation of the estimated regression line. Sometimes they'll say estimated regression equation. So bear in mind the question says write down. It doesn't say calculate. Ne? It says write down. It doesn't say calculate. So this is very important because we're not going to use the calculator here. You remember in the previous video what we did was we took the information that we had, we put it in our calculator, we calculate the value of A and the value of B. So now in this case we're not going to do that because we don't have to use the calculator. Information is over here. Ne? Alright, so for this question that says write down the equation of the estimated regression line, we're going to focus on the B parameter estimates. But before we go there, let's look at this over here. I just showed you that in our simple regression it was y equal a plus bx. So here it's not a plus bx, but it is y equal b0 plus b1x1 plus b2x2 plus b3x3 plus the error term. But now I don't want you guys to focus on the error term. I want you guys to focus on b0, b1, x1, b2, x2, and b3, x3. So basically, the b0 is the intercept. The b0 is the intercept, and then b1 is the coefficient of x1. X1 being the one of the independent variable. In this case, is the percentage of people who smoke. Ne? And then b2 is the coefficient of x2. X2 being the percentage of people who ride bike to work. And then b3 is the percentage of people who have extremely stressful jobs. Ne? All right. So now, as it is written here, x1 is smoking, x2 is biking, and x3 is stress. Right? So those are our independent variables. So now, when they say write down the equation of the estimated regression line, they want you to write it in this form. In this form, right? All right. So now it means we're going to say y estimated is equals to, what is the value of beta? 0 is the intercept. You're going to focus on the b parameter estimates, like I said, b parameter estimates. So basically your least squares regression equation is going to be equals to 17.473, because what? 17.473 is the intercept. I just explained that b0 is the intercept. So you're going to be 17.473, which is over here. Then you put a space, and then you're going to say plus what? The b1 over there is the coefficient of x1, which is equals to 0.208. 0.208. Don't forget to write x1. Ne? Do not forget your x all the time. Right, and then we're going to say minus. Why minus? Because it's written here as the next one, the estimate, the next coefficient is a negative, so it's going to be minus 0.229 x2, because that is the coefficient of x2. And then you're going to say minus 0.357 x3. So that is your least squares regression equation. It's 1 mark, so that is why you don't have to use the calculator, you don't have to stress a lot about it. You're just going to look at it over there, and then you're going to write it down. So you're going to say y estimated equals to 17.473 plus 0.208 x1 minus 0.229 x2 minus 0.357 x3. You just write it down like that, and you're going to get your 1 mark. Ne? It's simple as that. So in all of the questions that includes multiple regression, and they ask you about the least squares regression equation or the least squares regression line, that is how you answer that question. So that means we answered that question there, we got our mark, and simple as that. So We are done with this one. Simple. The next one says uh, calculate the dependent variable from given independent variables. All right. So for this type of equation, they will give you the independent variables. They'll give you the values of the independent variables, and then they'll ask you to calculate what? The dependent variables. Ne? All right. So in this case, that is question 1.7. It says, suppose there is a new town which wasn't part of the original sample with the following properties. Percentage of people that smoke is 68.66, percentage of people riding a bike to work is 60.27, and percentage of people with stressful jobs is 20.5. What do you expect the percentage of people with heart disease in this town to be? So this is a completely different town from the 30 towns that you did this research on, and you want to know based on the least squares regression equation that you have for that particular town, what would be the percentage of people with heart diseases? So we're going to use this exact formula to calculate that. Ne? How do we do that? First of all, we're going to substitute those values into this equation before we get to the calculator. Ne? First things first, we're going to substitute. We're going to say the estimated y is going to be equals to, you're going to write this in the 17.473 plus 0.208, and then x1 is given as what? 68.66. So into 68.66, you close bracket, and then you say minus 0.229 multiplied by x2 is 60.27, and then you're going to say minus 0.357 multiplied by 20.5, then you close your bracket. So that is your that is how you substitute this, and then now you go to your friend the calculator and ask for the answer. They're going to say 17.473 plus 0.208 multiplied by 68.66 minus 0.229 open bracket 60.27 close bracket minus 0.357, and then you say open bracket 20.5. So they will give you this values. They'll give you these values, and they'll give them to you in order so that you know, okay, this is x1, this is x2, and this is x3, right? And then after putting everything in the calculator, you press equal, and it will give you the percentage of people with heart disease in that particular town. So it's going to be 10.63%. So your estimated y is going to be equals to 10.63%. 10.63%. So you can even write it in weights and say 10.63% of people in this particular town are estimated to have heart diseases. Remember, this is just an estimation. That is why I say they are estimated, because we use the least squares regression line, the estimated regression line. So that is why I say 10.63% of people in this particular town are estimated to have heart diseases. So that's how you actually estimate the dependent variable, which is y, from a given independent variables, and that's literally how you answer that question. So they will give you sometimes they might not give ask you this question first before this. They can just say suppose there's a town, like the way they gave it to you like this, but without giving you this. So meaning you first have to have this equation, then you're going to substitute these values into this equation and get your answer. All right, so that is sorry about that. That is how you inter how you calculate the dependent variable from given independent variables. Done. All right, interpret the value of the coefficient of the independent variables. Okay, so this is one question that they like very much. Actually all the questions that are here they do like them, but yeah, this is one of them, né? Okay, so is it here? Is the question here? The question is actually not here, but okay. So basically, that question it says interpret the value of the coefficient of independent variables. The reason why I say independent variables and not say x variables, I want you guys to get used to this statistics language of saying what is an independent variable, what is a dependent variable. Now, so basically, the question wants you to to interpret these values. What does this 0.208 mean? What does this minus 0.229 mean? And what does this minus 0.357 mean? Ne? Okay, so for this one, I'm just going to go down a little bit for this one so that I give you guys an answer here. You can just write this in your notes and then, I don't know, cram it or something, but this is a standard answer for this. Now I'm going to give you guys a standard answer for this, and then I'm going to be practical as answering this question. So for this you say, for every unit increase in I'm gonna do this now, x1 or x2 or x3. For every unit increase in x1, x2, x3, why will, and then I'm gonna say increase or decrease with, I'm gonna say b1 or b2 or b3 units, provided that b1 b1 sorry b1 b2 b3 b2 and b3 remain constant. Okay, I want you guys to use this to answer each and every question that says to you interpret the value of the coefficient of a certain variable. They will say x1, x2, x3. Ne? So now, basically, from here, we're going to do what we call the method of elimination. Ne? So this is a standard answer, but you're going to remove some of them to answer that particular question. So let's say the question says, interpret the coefficient of x1. So now, what is the coefficient of x1? Coefficient of x1 is 0.208. That is b1. So they'll say to you, interpret b1, which is the coefficient of x1. In this case, is 0.208. Now, what you do is you're going to say, for every unit increase in that particular variable. So in this case, it's x1. Ne? So meaning that these two are out. So you're going to say, for every unit increase in x1, why will you go and look at the sign for that? Is it a positive or a negative sign? If it's a positive sign, then it increases. If it's a negative sign, then it decreases. For every unit increase in x1, y will increase. Why? Because it is positive. So decrease is out. For every unit increase in x1, y will increase with. So now, because we're dealing with b1, we're going to say b1 here. b2 and b3 are out. Ne? You're going to say it will increase in b1 units. Ne? provided that, so B1 is going to be out here. So provided that B2 and B3 remain constant. Ne? Provided that B2 and B3 remain constant. That is how you answer this. So if they say, for example, let's say they said, interpret the coefficient of x2, which is b2. B2 is minus 0.229. You're going to say for every unit increase in x2, meaning x1 and x3 are out. For every unit increase in x2, why will it is negative? So it will what? It will decrease. Increase is out. It will decrease with what? With b2 units, because we're dealing with b2, which is the coefficient of x2 units, provided that B1 and B3 remain constant. B2 is out. Provided that B1 and B3 remain constant. That's how you answer it. So now, that is the standard answer, like I said. If they said B3, you just do the same. Meaning here, you're going to say B3, you're going to say X3, and then look at the sign. If it's negative, you're going to say decrease with B3 units, provided that B1 and B2 remain constant. So basically, if you're dealing with B1, B2 and B3 should be constant. If you're dealing with if you're dealing with B2, then B1 and B3 are going to be constant, and so on and so on. I said B or X? I just want to confirm something. For every increase in X1, it's actually X is not here, not B. It's actually not the. It's actually not the. It's actually the X variables, provided that the X variables remain constant. Provided X1 and X2 remain constant. All right. Sorry about that mistake. So for every unit increase in X1, Y will increase with, you have to write the actual units, not B1. So I'm going to show you guys how to write the actual answer for this. It will increase in B1 units. So you're going to write the actual number for that units, provided that X1 and X2 remain constant. Basically, the other variables should remain constant, right? All right, cool. So now, this is the actual answer, because we don't want you guys to say X1, we don't want you guys to say B1. You have to write the actual answers. So meaning that in this case, you're going to say for every unit increase, but not just unit. In this case, we're talking about what? Percentage. We're talking about the percentage. So you're going to say for every percentage increase, for every percentage, for every percentage increase in X1. What is the actual X1? X1, they said it is the smoking. It is the smoking habit. So for every percentage increase in a smoker, let me just confirm the variables here. Yes, smoking. So it's a percentage of people who smoke. Okay. So for every percentage increase in smoking, let's say smoking, for every percentage increase in smoking, why? What is why? Why is the heart disease? So the percentage of heart disease, when I say percentage of heart disease will increase. It will increase. Why? Because the value of x1 is positive. Will increase with what? With 0.208%. 0.208%. The reason I'm saying this is, I said units, so the measuring units that we're using here, it's percentage. So this is just a standard answer for you to get to the actual answer. For every percentage increase in smoking, percentage of heart disease will increase with 0.208%, provided that biking percentage and stressful job percentage, stressful job percentage remain constant. So that's basically how you interpret the value of b1, which is the coefficient of x1. So if they set the value of b2, which is the coefficient of x2, you're going to say for every percentage increase in smoking. So basically here, it's going to be the same thing. No, not smoking. For every percentage increase in what? In what is x2 again? Biking. X2 is biking, ne? Percentage of biking. So we're going to say for every percentage increase in biking, the percentage of heart disease will decrease in this case because it is negative. It will decrease with 0.229%. It will decrease with 0.229% provided that smoking and stressful job percentage remain constant. So that is how you interpret the values of B1, B2, and B3. If you're still puzzled about this, maybe you see another question that you don't understand, please drop it down in the comment section and I will explain it further, or especially with that particular question. But basically, if you can get this, and then you do the method of elimination, and then after that you write the answer specially for that particular question, like I did here. First I wrote this, and then from there I do the elimination. After elimination, I write the answer specially for this information that we have here. That is how we interpret the values of the coefficient of independent variables. All right, so that is that question over there, or that study outcome. And then the next question that they like a lot, you will never see a question paper without this: calculate the value of the adjusted coefficient of determination. All right, so calculate the value of the adjusted coefficient of determination. First of all, we all know what is the coefficient of determination. I showed you guys in the past video. So the value of the adjusted coefficient of determination, the formula is given by r squared a is equals to 1 minus n minus 1 over n minus k minus 1 open brackets 1 minus r squared. Pardon me guys, I'm using my mouse to write because I don't have a writing tablet. I'm broke. Okay, so this is equals to this. So now before we get to answering this or calculating the adjusted coefficient of determination, first of all we want to know what are the meaning of these numbers here. So the value of n, it is the number of observations, it is the sample size. So it's going to be given to you, like in this case it is 30, ne? So n is the number of observations, k is the number of independent variables, the number of x variables. In this case it's going to be 3 because it's x1, x2, and x3. Sometimes it's 2, sometimes it's 4. I've never seen a question paper with 5, but it can get to that point. So it's the number of x values, and r squared is the normal coefficient of determination here. It's going to be given to you, right? So now we have everything. We can just substitute and say 1 minus, what is the value of n? It's 30 minus 1 over, what is the number of n? Is still 30 minus the number of independent variables is 3 minus 1, multiply by 1 minus, what is the value of r squared? 0.9614. 0.9614. Okay, now that we have this, then we can go to our calculator and find the adjusted coefficient of determination. We're going to say 1 minus, and then we're going to make our fraction 30 minus 1 over 30 minus 3 minus 1 open bracket 1 minus 0.9614. Okay, So this is equals to 0.9569. 0.9569. So that is how you calculate your uh, adjusted coefficient of determination. So here's just a tip from me. With the experience that I have tutoring this module, I experienced this. Um, it's a tip I've been giving students over the years. So how do you know, or how do you see that your adjusted coefficient of determination is correct? Ne? So the adjusted coefficient of determination, it's always going to be smaller than the normal coefficient of determination. Like for example here at 0.9614, the answer we got is 0.969569. So the answer is always going to be smaller than this number. But it's not going to be like way too small. For example, as you can see here, at 0.96, this is 0.95. So it's going to be like 0 point something 1 or 2 units at most. So basically if this is 0.9, we're expecting this to be like 0.95 like this, or 0.8 something, maybe 0.7 in a rare case scenario. But if you see it getting to 0.5, 0.4, then something is wrong. Or if this is bigger than this, then something is wrong. So you must go and double check your calculations. In most cases, in almost always the case, the adjusted coefficient of determination is smaller than the normal coefficient of determination. So that is how you calculate it. This is the formula. They'll give it to you in the formula sheet, and it's also open book. So you're going to be having your notes and your slides, so you can definitely know, as long as you know which formula to use. You don't have to know it by heart, like I do, but as long as you can know what these letters represent and how to substitute and get your answer. That is how you calculate the adjusted coefficient of determination. All right, on to the next. We're almost done. Determine which values contribute more or less to the coefficient of determination. Okay, so this part of the question is they will specify um, they will say which variable contributes the most or which variable contributes the least to r squared. Ne? So for that, you're going to focus here. So one thing that you must see in this multiple regression is that each and every question guides you somewhere. For example, the question about least square regression equation, we focus on the b parameters estimates under regression coefficients. When they say calculate the value of adjusted coefficient of determination, we focus on the model fitting statistics, which are the r squared and the adjusted r squared. And then now they ask you about what? About the contribution of the variables, and you're going to focus on the contribution of the variables. So now here you're going to focus only on the middle part. That's what you should know by now. You're going to focus on the middle part. Don't focus more on this one. This sometimes, but more in most cases you're going to focus here. Ne? Okay, so if they say to you which variable contributes the most to the coefficient of determination, you're going to say, you're going to look at the number that is bigger here. In this case, it's 0.2, 0.2940, this one over here. 0.2940 is the one that contributes the most. So meaning that x2 contributes the most. X2 contributes the most, and then followed by x1 because it's 0.1221, and the last one is 0.0087. So meaning that x2 contributes the most, x1 contributes after this, and then this one contributes the least. So if the question says which one contributes the most, you're going to focus on only this one. If the question says which one contributes the least, you're going to say it's x3. You're going to give the variable that contributes the least, not the contribution. So this is the contribution, and these are the variables that contributes. So the question asked here was asked differently. They said sort the three independent variables in terms of their relative order of importance, most to least, by making use of the contribution of the coefficient of determination. So the one that contributes the most is the most important, and the one that contributes the least is the least important. So basically meaning here, the answer is going to be x2, x1, then x3, which means it's going to be option B, x2, x1, then x3. So that is the contribution of these variables. Sometimes they will maybe let's say they didn't give you the contribution of x2, and they say to you determine the contribution of x2 to the coefficient of determination. So here you have the coefficient of determination, and you have this equation over here. This is more like an equation: r squared minus r squared I. This is r squared I. That's why I said you will use this sometimes. So if let's say this was not here, 0.2914, they say to you calculate the contribution of x2 to the coefficient of determination. You're gonna say 0.9614, which is r squared, 0.9614. And then you're going to subtract what? The this value over here, this value 0.6674, 0.6674, you say equals to, and the answer that you get is going to be 0.2940. If there's no number at the end, you know it's 0, so it's 0.2940. That is how they calculated that contribution over there. So that is how you determine which variable contributes the most or which variable contributes the least, or how to calculate the contribution of a certain variable to the coefficient of determination. And that's how you do it. So let's go to the next one. Determine which variable are statistically significant. Okay, so for statistical significance, that's actually study unit 5 in broad, but here it's just that simple 1 mark question basically. So you can see here 1.6, it's 1 mark. Indicate which variable contribute statistical significance to the model, and then they will give you what you call the alpha. In this case, alpha is equals to 0.05. Alpha is equal to 0.05. So for this one, you're going to focus on the probability. You're going to focus here. You're going to focus on these numbers. So they say indicate which variables contribute statistically significant to the model. Né? So for this one, we're not going to focus on the intercept. I'm going to focus on the intercept. We're going to focus only on x1, x2, and x3. So now, if that number, if that probability is less than 0.05, then you're going to say that variable is statistically significant, né? Or it contributes statistically significantly to the model. So if you look at x1 is 0.001, is less than 0.05. x2 is 0.001, which is also less than 0.05, followed by 0.023, which is also less than 0.05, 0.02 less than 0.05. So all the variables that we have here, all the independent variables contribute statistically significant. If let's say for example x2 was 0.14, for example 0.14, let me just write it down. Let's say for example x2 was 0.14, ne? 0.14 is more than 0.05. So if that was the case, then we're going to say 0.02 does not contribute statistically significant to the model. Ne? But in a case that we have here, all of them are less than 0.05, so they all contribute statistically significant to the model. So all the 3 variables contribute statistically significant to the model. That's how you answer that question. All right. So the last but not least thing that they can or they will ask you is based on the theory question of the assumption of normality. The assumption of normality, and that is based on the normal probability plot of residuals. So they'll give you they'll ask this question in the form of these 2 graph. So basically this graph, if you can look at it, all the points are aligned on this line. So in this case, we're going to say they are normally distributed. The points are normally distributed, and therefore the assumption of normality is met. So the assumption of normality is met, and if you can look at this points, they are not distributed on this normally on this straight line. So in this case, we're going to say normality is not met. And then they can ask you to calculate the residuals as well. They can actually ask you to calculate the residuals based on this, but you already know how to calculate the residuals. The residual is basically based on y minus y estimated. It's y minus y estimated. That is the value of the residuals. Sorry about this. Like I said, uh I'm using my thingy to my mouse to write. Let me just write it better. The residuals. Just gonna say res. The residuals is y minus y estimated. So in this case, they will give you the estimated y, and they'll give you the actual y. So you just have to substitute and calculate this. If you don't know this, go back to the first video and watch how you calculate the residuals. And that sums up the uh, study outcomes of multiple regression. So multiple regression is based on STAT 1.2, and they'll ask you these questions. All of these questions will be based on this model over here, STAT 1.2, and each and every question will guide you somewhere. If you just know, okay, if I calculate this, I'm going here. If I calculate this, I'm going there. If I calculate this, I'm going there. Then you should be fine. And with this, you should be ready for the quiz, and you should also be ready for the test, the first test that's gonna come based on Unit 1. I thank you guys, and I'll see you in the next video.